So this is my exemplar. I'm taking a look at the average daylight hours per month in Scotland. As of the year 2017, I took the data based on the 15th of each month for the number of hours of daylight in that particular month. So you can see here my months, January through December of 2017, and then the number of hours for daylight on the 15th of each of that month. So the data points in green represent the data from the table, and the graph is my overlaid equation. My independent variable is the months of the year. That is what is on my x-axis. My dependent variable is my average monthly daylight hours. That is what is on my y-axis. My midline was 12.25, and that represents halfway between the lowest and highest values, or the average yearly daylight hours. My amplitude is 5.5. This is the distance from my midline to the highest and lowest points, the maximum and minimum. In other words, the variation that occurs throughout the year. And my period is 12, which represents the months of the year that I looked at for 2017. Based on these key points, I created the equation y equals 5.5 times the sine of pi over 6 times x plus 4.7 plus 12.25. I had a horizontal phase shift of 4.7 months. And I believe that accounts for the fact that we really don't know what month time actually began. At some point in history, somebody stated this is the beginning of time. So we're not going on a actual 0 to 12 scale necessarily. So I had to take into account of that phase shift to get the most accurate graph that would represent my data. For my prediction, I wanted to predict how many daylight hours there would have been in July of 2019. So my X value was 31 to account for the number of months from January of 2017. And I would put that into my equation, and you can see that in the red parentheses. So when I calculated that out, my prediction is that there would be 16.8 hours of daylight in July of 2019. So in summation, graphical representations allow us to quickly show a picture of the phenomenon and make sense of the information shown. The equation allows us to predict future occurrences based on past data. My model is not perfect as it's limited by the amount of hours in a day. My data was taken for 1 day a month over a 1 year period. I feel that if I looked at decades worth of data, I would get a more precise equation, and this would allow for better extrapolation and predictions in the future.